Okay, hi everybody. This is section 8.4 in your book. It's the last section we're going to cover before the test next week. So it's the last new information you have for chapter 8. Also notice if you're looking in the book that we are skipping section 8.3. So we did 8.1, 8.2, we're going to do 8.4 today, and we're going to skip 8.3. Okay, so today we're going to talk about what is a rhombus, a rectangle, and a square, RRS for short. And we're going to learn about what the rules of RRSs are and practice finding sides of and angles in RRSs. So also what this section does is it presents all the polygons that we've studied and puts them in a map. And I think that'll help you understand how the polygons all relate to each other, which they do. Okay, so here is a polygon family tree. And the thing to remember, if you look at this top row here, come back. If you look at this top row here, you can look at that row maybe as grandparents, parents, as the great-grandparents. Okay, and this row here as the grandparents, and this row here as the parents, and this row here as the child. So the thing to remember is that the children, okay, all carry the characteristics of their parents and grandparents. So a parallelogram has its own definition, which is a quadrilateral with both pairs of opposite sides parallel, okay? But it also has all the characteristics of a polygon. Okay, remember a polygon is a figure that has three or more straight sides. So the parallelogram carries all the characteristics of a quadrilateral in that it is a polygon with four sides. Okay, so a parallelogram is a polygon with four sides, but it also has both pairs of opposite sides parallel, and that's what makes it a parallelogram. So here on the parent row, you have a rhombus and a rectangle. So a rectangle has all the characteristics of a parallelogram and a quadrilateral and a polygon, okay? In addition, a rhombus is a parallelogram with four congruent sides. So I'll change colors here. So all these four sides are congruent. Okay? Remember, in a parallelogram, we didn't make any assumptions about the sides. We know that they're parallel to each other, okay, but that's it. And so a rhombus takes that one step further and says, okay, it's a parallelogram, but the sides are congruent. And similarly, over here, the rectangle is a parallelogram with four right angles. Notice it didn't say anything about the sides, it just says four right angles. So the sides can be any length as long as the opposite sides are parallel, and it has four right angles. So below that, the lowest on our list, the child, is the square. And the square has four congruent sides, which it inherited from the rhombus. And it has four right angles, which it inherited from the rectangle. Okay. So the square has the characteristics of both the rhombus and the rectangle, as well as a parallelogram and a quadrilateral and a polygon. Okay, so the further down the list you go, the further down the tree you go, Okay, each item, square, rhombus, rectangle, carries all the characteristics of the lines above it. Okay, and that can be kind of a lengthy list by the time you get to a square. So we're going to go over each of those so we understand what we know about each of these figures, particularly the rhombus, the rectangle, and the square. Okay, and just to review, we know that from section 8.1, when we're talking about a polygon, that the sum of the internal angles is the number of sides minus 2 times 180 degrees, and you filled out that table, which I hope you're saving because it's very important. And we also know that the sum of the external angles of a polygon is 360 degrees, always 360 degrees. It doesn't matter if it's a triangle, quadrilateral, pentagon, hexagon, etc. Okay? So we know a lot of stuff, and this whole section is trying to help you organize that stuff so you can use it to solve problems. Okay. So this is just a restatement of what the RRSs are. So a rhombus is a parallelogram with 4 congruent sides. Notice how this sounds the same. A rectangle is a parallelogram with 4 right angles, 1, 2, 3, 4. And then a square is a parallelogram with both 4 congruent sides and 4 right angles. So it inherited its 4 right angles from the rectangle, and it inherited its 4 congruent sides from the rhombus. Okay? So you can look at it like the square is the most evolved polygon that we've worked with so far. Okay, here's another way to look at it too, in that if this is all of parallelograms, if this box is all parallelograms, okay, and what we know about parallelograms is their opposite sides are parallel, okay. Here we have rhombuses with 4 congruent sides, and here we have rectangles with 4 right angles, and they meet or they overlap in the middle. This is called a Venn diagram, and if you've done Venn diagrams before, these can be really helpful to understand what's going on. So the squares inherit and have characteristics of both rhombuses and rectangles, and that's really the point of this diagram. Okay, so just like we had with parallelograms in the last section, there are fun facts about rhombuses or rhombi. You can use either for the plural. And we know that the diagonals of a rhombus are perpendicular. So that doesn't mean that they're equal, and actually very easily you can tell that the diagonals are not the same length, okay, because the polygon has that slant to it, okay, but they are perpendicular to each other, okay, so those are all 90 degrees, and that will come in very handy when you start to do problems, okay. Now, a parallelogram doesn't necessarily have diagonals that are perpendicular, and most often it doesn't. So this is a rhombus, though, is special. It is different from a parallelogram because its diagonals are perpendicular. Okay. Now, another fun fact about the rhombus is that the diagonals of a rhombus bisect a pair of opposite angles. So it means this is your diagonal, this A to C. It's going to bisect this angle A, which means that the angle on this side is equal to the angle on that side. And because a rhombus is a parallelogram, its opposite angles are congruent, so it means that all 4 of these angles are the same measure. Okay. And similarly, you can look at the diagonal BD, okay, and by this rule that says the diagonals of a rhombus bisect a pair of opposite angles, okay, so here's angle D. And we know these two are equal because DB is a bisector of angle D. Okay, and here we have angle B, and we know diagonal DB bisects angle B, so we know that these two are the same. And furthermore, because it's a parallel, we know that they're equal to each other, but then they're also equal to the ones opposite. Okay, same thing here. Okay, angle A is bisected by AC. Okay, so each angle on the side of the bisector is the same, and not only are they congruent to each other, they're also congruent to the angles in the opposite corner, in the C corner. Okay, so this is what sets rhombuses apart from parallelograms. So let's take a look. Okay, given all that, oops, not on the right page here. Here we go. Okay, list of everything you know about rhombi. So we're going to put all that stuff together that we just talked about. Sorry, I'm getting my papers ready here. Okay. So we know from the definition on the previous slide, okay, and also on the family tree, that it is a parallelogram. Okay, and that's by definition. By definition, it has 4 congruent sides. That's also by its definition. And its diagonals are perpendicular. So we learned that on the previous page. So that was from the fun fact. And we know that each diagonal bisects a pair of opposite angles. And that was on the previous slide, which is a fun fact. Okay, so we can go over here. And it has 4 congruent sides, which are marked. Okay, its diagonals are perpendicular. Okay, and each diagonal bisects a pair of opposite angles. Okay. So that's a rhombus. Now, because it's a parallelogram, remember it's a child of a parallelogram, its opposite sides are parallel and congruent. Okay, they're not only congruent, but they're parallel. Its opposite angles are congruent, and we know that. Its consecutive angles are supplementary. So if you took this angle and this angle on a rhombus, okay, and you added them together, they would equal 180 degrees, okay, because it's a parallelogram, and that is a rule or a characteristic for parallelograms, okay, and we also know that the diagonals bisect each other, so they bisect, so this is half of this diagonal, this is half of the other, okay, and it bisects, so this half of this diagonal is equal to this half of this diagonal. But notice that they are not equal to each other, all 4. They're only equal to their twin on the opposite side of this bisector, okay? So that's how you develop an understanding about rhombi, is that it is a rhombus, and so it has these special characteristics of a rhombus, but then it also has the characteristics of a parallelogram because it is a child of a parallelogram on the Polygon family tree. Okay. No, we're not here yet. Hold on. Somehow these got out of order, but we'll fix that. Okay, rectangles. Okay, so a fun fact about rectangles is that the diagonals of the rectangle are congruent. So this means all of AC is congruent to DB. Okay, and because a rectangle is a parallelogram, just like a rhombus was, we know that these individual halves of the bisectors must be equal also. Okay, so that's a new fact about rectangles. That's only true for rectangles. Okay, so let's look at everything we know about rectangles. So because it is a rectangle, it is a parallelogram by definition. Go away. Okay, by definition, it has 4 right angles. By definition. Okay, and its diagonals are congruent. Okay, so that's what we learned. That's our fun fact. Okay, so these diagonals are congruent. Okay, now because it's a parallelogram, its opposite sides are parallel and congruent. Okay, so its opposite side is parallel to that side. This side is parallel to its opposite side. Okay, and they're also congruent. So I can make my parallel signs. Okay, its opposite angles are congruent, and we can see this because they're all 90 degrees. Okay, its consecutive angles are supplementary, so we could add this angle to this angle, and that would be 90 plus 90, and sure enough, that's 180, so they're supplementary, and its diagonals bisect each other, and that's pretty obvious here since these 4 lines are all equal to each other. So you know a lot about rectangles. And again, a rectangle gets its characteristics because it is a rectangle, but it also inherits the characteristics of a parallelogram. Okay? So let's look at the child now of the whole situation. Oops, back. Okay, so let's look at everything we know about squares. Okay, so because it is a square, and what's special about a square is it's a parallelogram, and it is both a rhombus and a rectangle. So it is inheriting characteristics from both the rhombus and the rectangle. So because it's a rhombus, it has 4 congruent sides. Sure enough, here they are. Okay, because it's a rhombus, its diagonals are perpendicular. Okay, and each diagonal bisects a pair of opposite angles. Okay, so those guys are all going to be the same. Those guys are all going to be the same. Okay, but actually because they are all 90 degrees, they're actually all equal to each other, which is very cool. Okay, now because it is a rectangle, it has 4 right angles, and they are congruent. Okay, and its diagonals are congruent, so all these guys are congruent. Now, because it's a parallelogram, okay, its opposite sides are parallel and congruent. Okay, that's pretty obvious. Its opposite angles are congruent. Yep, they're all 90 degrees. Its consecutive angles are supplementary. Okay, and just like the rectangle, you have 90 plus 90 equals 180. Okay, from consecutive angles. And its diagonals bisect each other, and we know that. So let's go back to our map, our family tree, just to kind of anchor that. Okay, so here's our family tree. And way down here is the square. The child is the square. And it inherited its 4 congruent sides from the rhombus. Okay, so here's our square, and it inherited its 4 congruent sides from the rhombus, and it inherited its 4 right angles from the rectangle. And the rhombus and the rectangle inherited the characteristic of being a quadrilateral with both pairs of opposite sides parallel. Okay, and obviously that works for a rhombus and a rectangle as well as a square. So the rhombus, rectangle, and square all inherited that from the parallelogram. Okay? And the parallelogram and everything below it, okay, all inherited the characteristic of a quadrilateral, which is that it is a polygon with 4 sides. Okay? So square is obviously a polygon with 4 sides. A rhombus is a polygon with 4 sides. Rectangle is, and so is a parallelogram. Okay, and polygon, okay, because it is a polygon, it only has straight lines, okay, and it can be any number of lines. But in this case, what we're doing is doing the family tree, the part of the family tree that's the quadrilateral, okay. So hopefully that makes sense. You might have to think about it for a while. But if you can understand this and put this picture in your mind, it will get a lot easier as time goes on. So, what we're going to do to work some problems that use this information. Okay, so this is a problem. It's from the book. It's a very classic problem that's used for teaching these ideas. So here you're given a rhombus, okay, and you're told, here's your rhombus, okay, the diagonals of the rhombus A, B, C, D intersect at E. Okay, so here's your intersection. Given that the measure of angle BAC, I think I'm going to use another color. Okay, the measure of angle BAC. So, measure, here's angle BAC. Okay. Oh, whoop, whoop, whoop. My bad, sorry. Okay. BAC, okay, it's just that half angle there, is 53 degrees. Okay, that's what they put down. And we're given that line DE is equal to 8. The length is equal to 8. So we need to find these 6 measures, 32, 33, 34, 5, and 36, and 37. Okay, so what I would advise when you do these kinds of problems, okay, is take the handout that you've just taken notes on and kind of spread it out in front of you, and so that you can easily access the facts. And for these particular problems, I would gather up, what's going on here? I would gather up all the information about a rhombus. So that would be the page Fun Facts About a Rhombus, and also the list of everything you know about rhombi. Okay, that would be very handy for you to have right in front of you while you try to do these problems, or this problem. Okay, so let's look at 32. So we're going to look for the measure of angle DAC. Okay, let me get this right this time. DAC. Okay. So, and I'm going to write it all down here. So we know that BAC is equal to 53 degrees. Now, what is it about a rhombus and all its characteristics that tells us what the angle DAC is? Okay, and if you look at your list, And you look at the statement that says each diagonal bisects a pair of opposite angles. It's the if you look at your paper list of everything you know about rhombi, it's the fourth one in the first group because it is a rhombus. Each diagonal bisects a pair of opposite angles. Okay, so that means that this diagonal AC bisects angle A. So it bisects, which means that this angle and angle BRC are equal, and DAC is equal to 53 degrees. So angle DAC is equal to 53 degrees because, I'm going to shorten because, okay, because the diagonals of a rhombus bisect opposite angles. Okay, so that's your reasoning. So when you do this on your homework and also in quizzes, you can say what it is, but then I also want to see an explanation. Okay, why are you saying that angle DAC equals 53 degrees? And you're going to find all those justifications, all those reasons in your list of everything that you know about the figure. In this case, it's a rhombus. Okay, so let's look at number 33. Okay, so I'm going to erase what's on there because I think otherwise it's going to be really hard to see. Because we're kind of looking at different things here. And I'm going to change color. Okay. Okay, so we're looking at the measure of angle EAED. Okay, here's AED. Okay. So, what fun fact about rhombi would allow you to know what the measure is of that angle AED? Okay. And if you look at your list of everything you know about rhombi, okay, number 3, because it's a rhombus, says its diagonals are perpendicular. Its diagonals are perpendicular. And AC and DB are diagonals, and they are perpendicular. So perpendicular means that that angle is 90 degrees. So measure of angle AED is 90 degrees. Because diagonals of a rhombus are perpendicular. Okay. So I'm going to change colors. What should we do? Okay, let's do number 34. So we're looking for the measure of angle ADC. Okay, I'm going to erase the green stuff. So now we're looking at ADC. So we know that angle A, from the work we did in 32, and we know that DAC is equal to 53. So we know this is equal to 53 degrees. Okay. So we know that this whole angle has got to be 53 plus 53. 3 and 3 is 6. It's got to be 106 degrees. So we know because it is a parallelogram that the consecutive angles are supplementary. So if this is 106 degrees, okay, the angle next to it, which just happens to be angle ADC, okay, is supplementary to the 106 degrees. So all we need to do is take 180, subtract 106, and we end up with 74. So the measure of angle ADC is equal to 74 degrees. Okay? Because ADC is supplementary to angle DAB, because they are consecutive angles. In a parallelogram. Oops. You know what? I'm going to go the short route here, and I'm going to say, I'm just going to draw in a parallelogram. Okay? So you had to know, you had to remember that the angles, those consecutive angles in a parallelogram are supplementary because rhombus is a parallelogram, and so it carries the characteristic of a parallelogram, which says that they are consecutive. And once you know that, then all you have to do is calculate those angles, and you've got it. Okay, so let's go on to 35, but I'm going to erase. I'm going to erase all this for now. Make it all nice and clean. There we go. Okay. I'm tired of that color. Let's do something else. Ooh, purple. I haven't done purple in a while. Okay, so now we've looked at all these angles, and now they're going to ask us about the line segments. So let's look at 35. So they're looking for DB. Where is DB? DB, okay, it's this diagonal right there. So now we know, because this is a parallelogram, that these two diagonals, DB and AC, bisect each other. Okay, so we know DB is equal to 2 times 8 is equal to 16, because the diagonals of a parallelogram bisect each other. Okay? And that's it. You didn't even have to really know it's a rhombus, okay? But it was just the fact that it's a parallelogram allowed us to answer that question. Okay? So let's change colors. Okay, 36. We're looking at AE. Okay, we're looking at AE. I'm going to erase. I don't think we need to know that either. Let me do this. So we're looking for AE. So we know that this length, DE, okay, is equal to 8, because we're given that. Okay, but we have no idea what this length is, because remember, the diagonals of a rhombus are not necessarily equal to each other. Okay, that's reserved for the square. Okay, so so we have to do something tricky here. So what do you think? So we know this angle, let's call it theta, anything ringing a bell, is equal to 53 degrees. Okay, we know this is a right angle because we've already shown that, because the diagonals of a rhombus are perpendicular to each other, okay? And then we know this length. So how about that? We have a theta of 53 degrees, we have a right angle, and we have a line of 8, segment of 8. I think some trigonometry is in our near future, okay? So let's take this apart. Okay, so here's D, E, A, okay, and here's our theta, and here's our length, and we know theta is equal to 53 degrees, okay. So from chapter 7, okay, if this angle is theta, you should remember that this length is opposite of theta, and this length, the one we're looking for, is adjacent. So we know our opposite, and we want to find our adjacent. So if we think of SOHCAHTOA, which of the three functions, sine, cosine, or tangent, uses the adjacent and the opposite? And if you remember, that's tangent. So tangent of theta equals the opposite over the adjacent. Okay, so in our case, the tangent of 53 degrees is equal to 8 over the adjacent. So now we have to do a bunch of stuff to calculate that. So it turns out the tangent of 53 degrees is equal to 1.3720, and that's just by looking at the trig tables. Okay, so we know that 1.3720 is going to be equal to 8 over the adjacent. So going back to our algebra days, we're going to multiply both sides by the adjacent. We're getting a little squish there. 80j times. Okay, so this goes away, and we know the adjacent times 1.3720 equals 8. And we need to isolate that adjacent. So we know the adjacent is equal to 8 divided by 1.3720. So you're going to go to your handy-dandy calculator, and you'll get a number that looks something like 5.83. And if you want to, you can round that up to 6. Okay. So now we know that this length right here is equal to 6, give or take a little bit. Okay. Now we're looking for AC, that's number 37, and AC is this right here. And the same way that we figured out DB, okay, we can figure out AC. So we know that this is a bisector here, so this side has to be 6, and so AC has to be 6 plus 6 is equal to 12. Okay, so that's a lot of work, but that's what these problems are all about, and you will have one like this on the test, so it's best to practice. So what your homework is over the weekend is that there are 2 more problems just like this, just 2 problems. One is on a rectangle, so you're going to have to use your notes on a rectangle. And then the other one is on a square. And it asks these same basic questions to find measures of angles and find lengths of sides. So when you do them, you should sit down, okay, with your homework paper. And this is a homework that's on paper. You'll get it in class, or you can get it off of Google Classroom. So you're going to sit down with the homework paper and your list of everything you know about rectangles, so you can answer the rectangle question, And then you're also going to have your list of everything that you know about squares, so you can answer all the questions about squares. And if you're careful about it and you do it just exactly like we did this one, going through it step by step, calculating what you need to calculate, and also explaining why, okay, you were able to do that calculation, then everything will go great. And we can talk about it more on Monday and get you ready for the test. Okay, good luck. And again, email me if you have questions, and I'll be around all weekend.